Hello, and welcome to this workshop on building a REST API with Node, Express, and Mongo. Well, let's begin with the agenda for today. We're going to start with touching upon some of the concepts related to this topic, followed by the installation of the environment, and we will start with setting up the application before we dive into the crux of this workshop, which is to set up a Express web server, and then we're going to connect it to MongoDB via Mongoose. And I have a bit of a stretch here. If we have time, I want to show you how to deploy this application using a service called Node.js. So let's start with concepts around HTTP, REST, and APIs. So what is HTTP? It stands for Hypertext Transfer Protocol. Now, hypertext is basically text that can link to other text. Hence the word Hypertext Transfer Protocol, because that's being transferred. It's an application layer protocol. It's built on top of the TCP/IP protocol. What that means is it's using TCP/IP for communicating, but then there's application layer logic on top. It pretty much defines all the rules for transferring resources between a client and a server. Now, every HTTP request is executed independently. So on the server side, it does not have knowledge of any of the requests that came before it. And that's what makes HTTP stateless. But here's an interesting thing. It's built on top of TCP/IP, which is not stateless. So how does that work? Basically, when you send an HTTP request, it's issuing a connection via TCP/IP to the other site. It could be a server or the client. And the TCP/IP connection stays connected. HTTP will send what it needs to, and then it's going to disconnect. Hence, it's known as stateless. One of the cool things about HTTP is that you can transfer anything in the body as long as the HTTP headers define what is being transferred. So for instance, if you have an image versus HTML file versus a JavaScript file embedded in your body, then you need to specify the content type in the header. And that's how the receiving end knows what to do with it. Now, let's talk about REST. It stands for Representational State Transfer. It's actually an architectural pattern with design guidelines. HTTP is usually the underlying protocol when you're implementing REST, but REST can be implemented on other protocols. It hasn't been used as much though. What HTTP provides us is basically a set of methods that need to be used explicitly by the REST pattern. Every RESTful resource has a unique ID, which makes it interesting because you can reference different things over the internet via a specific URL. Now, client state is not persisted between requests. So that's what REST basically states that we should be doing. However, that state can be passed along to the server via some attributes that help the server decide how to process that request. REST also states that the application should define a caching policy for responses. What that means is it allows the client to make a decision on the received content, and they can decide to either keep it in their cache and serve it from there, for subsequent requests so that it improves the application performance. It also dictates that there should be separation of concerns between the clients and servers. What that means is the client does not care about what is the memory usage on the server or what the setup is of the hardware and things like that, and vice versa. That's also a layered system. So the client doesn't really know if it's talking directly to the host server or if there are other intermediate servers such as proxy servers or edge cache servers and things like that. Now, let's talk about what an API is. It stands for an application programming interface. Basically, you have functions that are defined on the server side, and the API tells you what is supported from the server and where the request should be made. So essentially, it's going to tell you what the pattern of the URLs are that you're going to use to call into the server. Pretty much, it's telling you what the format of the request and response is. Now, there's no standard way of writing APIs, and that's what makes it somewhat powerful, but at the same time, it's a bit scary because every system will vary so much. And so that's where REST comes in. It provides us with guidelines on how these APIs should be constructed. You're going to hear about something called a CRUD operation over and over when you're using REST. And all that stands for is, it's an acronym for creating, reading, updating, and deleting records. So essentially, when you're making a call over an API, you're performing one of those 4 operations. Anyway, let's get started with the installation. I had a note about this in the workshop description, so hopefully you are all set up with this, but I quickly want to touch upon what this entails. So we need an IDE where we're going to write code. You need Node.js installed. Usually NPM is part of the Node.js installation, so you should be good there. We're going to use an instance of a Mongo database in the cloud via mlab.com. And then one of the things I forgot to mention was that we need a REST client. And I'll get into the details there, something like Insomnia or Postman. And then finally, Robo3T, which allows us to look at the data in Mongo. So as for the IDE, you have 3 different options: VS Code, Atom, and WebStorm that I would recommend, but there are a ton of IDEs out there. You want to find something that's going to help you with the language and the framework that you're working with. And all 3 of these are very powerful and customizable. As far as Node.js is concerned, you can get any latest version of Node.js, and we should be good. That should have the latest package manager. There is a subtle difference, so if you have version 5, you don't need to use the save command because it automatically saves everything in the package when we install any of the packages. And then as far as coding today, we're going to use the natively supported ES6 and 7 that's available in Node. That way we don't have to set up Babel or any other transpilers. If you can go to node.green, you'll notice that it lists out all the features that are supported by Node. And this gives you a good idea of which version supports what feature in ES6 and 7. Sorry, we're trying to figure out the video here, and some reason it's not running. Just give me a moment here. I'm not sure what's going on there, Lana. Anyway, let's continue for now. So MongoDB can be installed locally, or you can get an instance via the MLab cloud. And at the same time, if you are a fan of Docker, you can use Docker to deploy it somewhere or install it locally as well. We're going to use MLab for this workshop because it allows us to easily deploy the application and not worry about a Mongo installation during deployment. As far as the REST client goes, we're going to use it to test the API that we build. And I prefer Insomnia because it's pretty lightweight, but Postman is also very powerful. Now, I got a question here about if I have any experience with WebStorm and what do I think of it. So I've used several IDEs over the years, actually 20 some years, and I really love WebStorm because it allows you to do things that most of the other IDEs require you to configure it from scratch, like VS Code, for instance. There's one subtle aspect of VS Code that I dislike compared to WebStorm, and that is you cannot get multiple console windows in a tabular view. They have sort of a drop down, and so you can quickly switch between those windows. And I'm sure there's a plugin out there, but I haven't found that yet. As far as, there's another question here, which says, things like MLab seem way more popular in Node world. Do you have any thoughts over why this is the case compared to other ecosystems? I believe Mongo is an integral component of most Node applications, mainly because you're coding in JavaScript, all the way from the browser to the backend, and it lends itself very well to Mongo as well because you're storing JavaScript objects or JSON. And then what that means is you don't have to go through conversions for your data compared to other databases. Now, using MLab specifically, they have a very good interface and they provide you with a free starter database that you can get, I think, up and running within a minute, literally. So it's naturally the preferred option because it saves you a lot of time from having to configure it. Getting back to this, if you guys can download Insomnia or Postman, you should be able to follow along with testing the API. Now, as far as getting started, we need to set up the application first so that we can start to code the APIs. So we're going to start with creating a project folder, and then you will open up your IDE, either whatever it is you're using, in that project folder, and then we'll start to construct other subfolders and files there. So what I'm going to do is I have a slide outlining what we're going to accomplish, and so I will keep switching between the slide and WebStorm as we complete these tasks. So in this case, we are initializing our node and then creating a very, very basic hello world script actually. And then we're going to set up some startup scripts that allow us to run our application, and then we'll build from there. So here is my WebStorm instance. I have a folder that's created here. What I'm going to do is in the console at the bottom here, I'm not sure if I can increase the font in the console, but I will in the code. What I'm going to type is npm init. And I just want to make sure I'm in the correct folder here. I am. Okay. So I will type in npm init, and then I will provide an optional parameter called -y, which stands for simply don't ask me any questions, just generate the package JSON file. This is what npm init will do, is it'll create a package JSON file under your folder, and it has a few attributes there that define what this project is going to contain, especially if you were turning it into a package that you wanted other people to consume. That's where some of these attributes come into the picture. So in addition, it also allows you to set up some scripts that you can run as npm commands, and we'll get to that in a bit. So let's start out by creating a folder under our root and call it src, which stands for source. Now under the source folder, we're going to create another file, a JavaScript file, and we're going to call it index.js. Usually in WebStorm, and I think most IDEs, if you leave out the extension, it'll automatically create it. And let us simply type in a console log statement here, and we will call it hello world. I'm going to save this file and then go down to the console, and I can run it by typing in node and then pointing to the file. So it's under the source folder / index.js. And there you go. You will see it print hello world. So pretty much it has executed this file that we created. Very simple. Now let's make this a little more, let's add a helpful command to our package.json so that we don't have to keep pointing to the file and typing in node source index. So what I'm going to do is modify the scripts section of package.json. We're going to add a command called start, and what we're going to put in there is the exact same command that we typed at the bottom of the window here. And this runs relative to the project root. I'm going to save that. I will clear my console, and I'm going to run npm start. Notice that it ran our command here, and then you'll see the output at the bottom. So start and test are two commands that you can run via npm without an intermediate keyword called run. So normally, most of the commands require you to type in npm run and then the name of the command. So npm run start works as well, except for Node made it a little easier. Sorry, npm made it a little easier by allowing us to just do npm start. Very well. I'm going to switch back to our presentation window here. All right. So hopefully everyone's caught on to that. Next, let's get started with Express. Express is an npm package, and it is basically a lightweight web server. What that means is it's taken all the Node.js HTTP classes and added a layer on top of it so that it can communicate, or so that it allows you to communicate via RESTful endpoints. Let's start out by installing the Express dependency, and then we're going to reference the library and create a very basic Express application. So going back to the console here, I'm going to type in npm install Express. And if you're using npm version 5 and above, it automatically saves it to your package.json. So look at my package.json here, and you'll notice that there's a dependencies section that showed up. And what this means is that when the project is running, it's going to have Express available to it. Next, we're going to switch over to the index.js, and you can get rid of the console log here. Let's start out by referencing the Express library. So we're going to type in let express equals to require express. Next, we want to create an application. So we're going to call it app equals express, and you can open and close brackets, and that creates an Express application. So one of the things we want to do now is have this Express application serve some content. So let's start out by serving some static files. So I'm going to create a folder under the root, and I will call it public. This is where we're going to store static resources like HTML files, your images, JavaScript, CSS, and things like that. So let's create an HTML file here. I'm going to call it index.html. Let's give it a title, and then in the body we'll put in some text. I'm going to save the file and go back to index.js. So the way you can serve static content in Express is via a function called express.static. So I'm going to tell Express to use this specific static file handler. This is also known as a middleware, and it's built into Express. So what I can do here is express.static, and then I will pass in the name of the folder that I want to serve content from, and that's public. This is relative to the root of the project. And finally, we want Express to listen to a port on the machine. So we're going to do something like this. Actually, let's create a variable here, and I'll tell you in a moment why. So let's call it constant port, and we can read this port value from the environment variable. It's something that's defined on the command line before you start the project. Or if that's missing, we can substitute 3000 for it. So I'm going to do process.env, which is environment.port. And then if that does not exist, we're going to default to 3000. So I will substitute this 3000 here with the value port. And then let's simply output a message that says server. I'm going to use these backticks here, so I can introduce a variable in there, and let's call this server has started on the port that it's actually running on. So that way we know where the server is running. Oops, I missed the en there. All right, so we're going to go back and run the server here again by calling node. I'm sorry, we have the script command, so we're going to do npm start. And there you go. You see that a message that says server has started. And notice that the program is still running. That's because the server's running and it's not going to release control until we stop it. And the way to stop it is to push Control-C. Anyway, let's switch over to a browser window. And what I'm going to do is try to, oops, sorry. That's 3000. And so there you go. You'll see the message that we typed into the HTML file. So this is very simple. It allows you to actually put any file in the public folder, and you can serve it through a URL here. So essentially what this is doing is defaulting to index.html, the file that we created. So if I type this path, it still loads the same content. All right, so now I'm going to switch back to our slides here. And so we've accomplished these things here. Let's move on to the next, which is, actually I had a slide here for serving static content. So where essentially we created a public folder under root, an HTML file, and we configured Express to serve that static content. Now, let's get on to something more interesting. We're going to create our first API endpoint. And API endpoints are usually set up with HTTP verbs. So you may have heard about something called a GET request. And what that's essentially doing is making a call to the server with the GET keyword, and the server's responding with some content. We'll also talk about a couple of other attributes in that request called request parameters and query parameters. So let's head over to WebStorm again. And what I'm going to do is create a folder under source called routes. And then let's create a file called person.js. We're going to create what's called a route in Express. They're basically, you can consider them as mini applications, and there are advantages to it, and I will talk about it in a bit. So essentially, we want to start out by referencing Express here, followed by a router from that Express instance. And then towards the bottom of the file, we're going to export that router. What that allows us to do is now import it in the index.js file. Now let's go ahead and add the route we were talking about earlier. And I'm going to call it person. So we're making a call to get a person object here. And usually a route has a callback method that gets called when you make that request. So in this case, it's going to have two parameters, a request and response, and then we're going to do something with it. So let's do something very simple here. Now, Express makes things easier for us. Some of these things you see here are things we would have to code normally. And in this case, it allows us to do something very simple, like send a message here. So let's call this, you have requested a person. Essentially, this is a route that we've created that can be accessed via localhost :3000/person. And that's what it's going to respond with. Now, before we go back to the browser and try this, we want to go into the index file and then reference that file that we just created. So let's call it person route equals require. Oops. And we're going to go into the routes folder /person. You don't need to specify the .js extension. And then finally, we're going to tell Express to register this route. Oops, person route. All right. Now, notice that we have to go down here now and stop the server and restart it, because it's not going to pick up the changes that we just made automatically. Anyway, so I just restarted the server here. We're going to go to the browser again and call that route we just created. So localhost 3000/person, and there you go. That's how simple it is to create an API endpoint. Of course, this is a very basic version of that. Now, before we continue, I want to do a couple of things here. I want to show you how to use this tool called Insomnia, or you may have installed something called Postman. So essentially, this allows us to test the APIs that we are creating. So let's go ahead and create a request here. I'm going to call it get person, and it's a get request. You can change this later on, so if you get the wrong thing there, it's okay. You can go up here and change it to a different kind of request. One of the things I forgot to mention was that CRUD operations map to 4 requests. You have the create, which happens on a post, the read, which happens on a get, the update happens on put, and delete happens on delete. So we have a question here. When would changes be picked up automatically, and when do you need to restart the server? Coming from Rails world, wondering about how things are different. So we need to set up a command and reference a library that will monitor our project for changes. So we'll do this right after the Insomnia piece we're looking at, but the changes are picked up based off the files that are monitored. Any sort of a change in that file, once it's saved, will restart the server. Is Insomnia better than Postman? So I started out using Postman, and I haven't touched it in a while, so I don't recall exactly, but from what I remember, Insomnia was a lot easier to work with. It was much more intuitive in many ways compared to Postman. I think Postman might have improved. They do have a lot of advanced features too that I don't think Insomnia does, but for our purposes here, the Insomnia works just fine. This is actually what I use on a daily basis. I haven't gone back to Postman in a few years now. So we wanted to talk about accessing the person route. So what I'm going to do is put in the URL for our server, and then in this case we're going to call person, and then I can either enter or click send here, and there you go. This allows us to define all the different routes that we've created and test them out over here. One of the things that Postman lets you do is generate test cases from these routes, and they have additional tooling there. So I would definitely encourage everyone to check out both these tools. I think Postman is definitely valuable. Sometimes I find it a bit too bloated, but they're both very similar. So in this case, I think what REST API, what getPerson allows us to do here in Insomnia is also generate some code that we can then test out through Node or any other project. So I'm going to click on that real quick, and then notice that it has a bunch of languages here. And so essentially you can pick something. So let's say we were doing this in Node.js, then I have the option of choosing which type of library that it's using to make that request. And I generally would choose request because it's the shortest piece of code here. And it's essentially setting some attributes here and then making that request to the endpoint. And I can copy this and then paste it in my test file and then sort of go on from there. All right, so that's that. Let's go back to WebStorm. And we're going to now talk about setting up a script that allows us to monitor for changes so we don't have to restart the server. So the first thing we would do is, let's stop the server here. We're going to install something called nodemon. Now there is an alias for install. I could just use I instead of install, and nodemon is what I want to install. Now prior to npm 5, you had to specify things like save, which would save it as a dependency in package.json. However, in this case, because we're using the latest Node version, npm version, we don't need to do that. But nodemon is something we're going to run during development only. So we would specify either save-dev, or there's a shortcut for, or a short for it, which is -d. They both do the same thing. So what that's going to do is create a dev dependencies section here in package.json. And those dependencies are only available during development time. So basically, if you were to deploy this through a CI system like Circle CI, it's going to do npm install when it downloads the project. And all that is going to do is install dev dependencies. All right, so we have NodeMon created here. What we're going to do is learn how to use it. Actually, let's just put it in a, let's create a command here. So we're going to call it start watch. And all we have to do is NodeMon and point it to a specific folder here. Actually, we can just do the file in this case. And so we can run it with npm run. Remember, we need run this time because it's not the start or test command. And then that's going to monitor this specific file for changes. You can also specify folders to be monitored and things like that. And it's going to internally run the startup file and monitor a set of folders. These are things you can look up in the documentation as you get acquainted with these various libraries. All right, so let's go back to the slides again. Sorry, this requires me to switch things around a bit. So we talked about a GET request. Next, let's focus on a couple other attributes that can be passed through. So I'm going to go back to WebStorm here into the person.js file. So we're going to create a couple more routes around person itself. So what I'm going to do is copy and paste this down here. And one of the things that we want to be able to do is, let's say, pass in an additional sort of sub-route that can be mapped to a variable. So let's call it name, and we need to specify a colon before it, so Express knows that it needs to map that to a variable. And these variables here are available through the request object in a property called params. So let's just print that out here. I'm going to put a comma there. We can do request.params.name. And I'm going to, oops, sorry, I thought this was console log. I'm going to change this to a template. So I'm going to do the backticks. That allows me to treat this as a variable in my state string here, and I will close it with the backtick. So that basically is the same as doing you have requested a person plus space plus this. All right, so let's save this, and notice that our server automatically restarted. So we're going to go to Insomnia, and I'm going to create another route here. I'm going to duplicate this by right-clicking and picking duplicate, and then let's call this get person by name. And all I have to do in the route here. Now, as I switch between these, it's choosing the right. So it's showing you the output for whatever's stored there. So when I make changes to get person by name, it's not going to affect person. So I can go ahead and do that here, and let's call it. Let's give it a name here, and then I'm going to click send. And so it's simply responding back with the parameter that we passed in. All right. The other thing we can do is, so this here is a params object or property on the request object. What I also want to do is allow us to pass in a query string, which is a query string is basically a query property on the request object. All right. So the way to accomplish that is simply by checking the query object here. So let's say we look for request dot query dot let's call it name as well. So that's what we're going to pass in. Then we will do something there. Else we're going to handle it like we were originally. So in this case, I'm going to copy this thing over here again from line 16 to line 7, and I'm going to replace params with query. That's the only difference really. So what this allows me to do is basically call something like localhost 3000 /person with what's called a query string. So anything after the question mark is basically a part of the query string, and it's a key value pair. So I could essentially add additional key values here by adding an ampersand. So let's say name and age equals 20. So this, we're not doing anything interesting right now. We're simply echoing whatever's passed in, but this is what that allows. And in case of params, this allows us to do something like this: localhost 3000 /person /name. So that's the difference here between the two. This is part of the route, and that is part of the query string. All right, so I'm going to save this, and let's go back to Insomnia. And in the get person piece, I guess we can duplicate this as well again, and then I'll call it get person by query string. And so all I have to do here now is specify the name and click send. There you go. So we have 3 ways of accomplishing the same thing. Or I'm sorry, 2 ways here by specifying a parameter. So this is by query string and by params. So I'm going to rename this just to make it clear. So there, get person by params. All right. Okay. So hopefully this is clear enough so far. Moving on. So we talked about middleware, and we set up a middleware earlier called static, which is part of Express. Now middleware are simply functions that are executed back to back or serially in the request pipeline. So when a request comes in, there are a bunch of functions. Think of it as an array of functions, and they execute from the index 0 all the way to the end. And each one calls, when it's done, calls into the next function. It has the ability to also modify the request and response objects and pass in additional details downstream. Or it can also decide to respond and not call into other functions downstream, because maybe the incoming request was meant to be handled by that function. So I think I covered through all these things here. And yeah, so let's go ahead and look at some code and see how to do that. So the easiest middleware for us to set up is to log every request that comes in. So we're going to accomplish that by going into index.js, and note that the order in which these handlers are added matters, because that's how these middleware functions are pushed onto the array and executed in that same order. So it's possible that person route sort of is the function that is supposed to serve the request, and it ends up ending the chain of functions that are called. So we want to actually print out the incoming request as the first thing, so that we can catch everything that comes in. So we do that by calling app.use, and we're going to set up a function right in place. And middleware functions take 3 parameters. You have the request and response, just like the other routes that we created. But there's also something called next, which is a reference to the next function in the pipeline. And in this case, let's just console log a few things here. I'm going to use the backticks again. Let's put in a variable here, and I'm going to create a new date object, and I'm going to call toString on it, which will print a long version of the date and time, I believe. And then we're going to also, let's say, list out the URL that was requested, which is under the original URL attribute of the request object. And we can, in the future, we'll modify this after a few more changes. So I saved this, and what I'm going to do, the thing I forgot here is that we need to call next after we're done. Otherwise, it's going to break the chain of functions that are called in that pipeline. And essentially, if I wanted to just respond from here, I would do something like response.send is one way to sort of respond back, and then not call next, and that'll break the pipeline. However, if I don't respond to it and I don't call next, then the user is going to be waiting for that request until it times out. So we have to make sure that we call next here and remove the response in. All right. So what's going to happen here is basically we're going to see things printed out here. Sorry, I'm just taking a look at what's going on here. That's probably from what we had up there. I'm going to clear my console, and let's go ahead and make a request in Insomnia. So I'm just going to call the same route again and go back to WebStorm, and notice that there is a line that's been output here which prints the long form of the date time and the URL that was requested. So there you go. I mean, this is a very powerful concept because now you can inject functions that do things for every route in the system. And you can choose to ignore it and not do anything and then just pass the control along to the next function in the pipeline. All right, so going back to our slides here. So another thing we can do with these middleware is handle 404 and 500 errors and other errors and things like that. And so let's go through how that's done. We're going to respond back for 404, let's say with some content initially, a string, and then I can also show you how to respond with a specific file. All right. So for a 404 handler, all you need to do is add a middleware function towards the end of the chain. So the express.static is the last thing we have in our chain at the moment. And so I'm going to add a middleware function here that's going to take the same request, response, and next parameters. And essentially what this is a handler for the error 404 not found, or resource not found. And what we're going to do here is respond with a status code that says 404, and we're going to send a message. It says, "We think you are lost." All right. So let's go ahead and test that. All we have to do is let's go to Chrome in this case, and let's just put in any random string here and hit enter, and there you go. What happened here was basically there were no middleware functions to handle that request. Sorry, I missed a question here. The question is, anecdotally, is using the IDE's terminal slower than running terminal as a separate app? So I don't think so. It really comes down to what you are most comfortable with and most efficient with. I always shoot to sort of improve my sort of agility, and so depends on various factors. And in this case, it's easier for me to stay within the context of the IDE so that I see things that are happening right there. Because I could have a build process, I could have a test process and various things right there, and I wouldn't have to switch between windows. But essentially, that's something you could do as well. I do use a separate terminal window when I'm using VS Code because I don't like the integrated terminal there. So there is no sort of right answer here. It's really your preference. I don't think either of them are slow. All right. So we handled 404. Now we're going to handle error 500. And what that means is we're going to add another handler here. So handler for error 500. And so we're going to do app.use. Now the only difference here is that this takes an error object. So it has 4 parameters compared to the 3 that we've been using so far. And essentially, we're going to, let's say we're going to print out the error to the console. So there is a property called stack. And then we're going to, let's do something different here. We're going to go to the public folder and create a file here. And let's call that file 500.html. And so we'll simply print something went wrong here. All right, I'm going to save that file, close it, and then we want to serve this file as the response instead of some text message. So one of the things I need is to reference the path module. Oops. And then I hope you saw that. And then go down here, and we need to use the send file method that Express provides us. And we're going to path.join a couple of things. One is the root of the folder, which is referenced to with dir __ name. And I'm sorry, that is where the project is running from. So the main index file is under source routes. And so we're going to go up to, I'm sorry, it's not source routes, it's under source. So we're going to go up to public, which is one folder above, and then we're going to serve 500.html. I think I got that right. Yeah, so essentially index is here, the dot will tell it to go up to the root, and then we're going down to public in 500 HTML, and we're combining that path, and then Express will look up the file, read in the contents, and send those out with setting the right headers and things like that. All right, so I saved that, and now let's say the only way for us to trigger that is through an error. So what I'm going to do is let's go back to the routes file, and we're going to create a route here that's going to generate an error for us. So I'm going to call it /person/error, and we're going to do request response. So in this handler, all we're going to do is throw a new error. So what's going to happen is anytime we call this endpoint, it's going to trigger some exception, and since it's not handled, it's going to end up in this part in the 500 error handler. All right, so I'm going to save that and then go back to our browser here, and then /person/error. So there you go. I think that's what I printed here. Oh, we're not responding with that specific error. I think. Oh, I see what's going on here. Sorry. Let's call this something else. I'm just going to call this /error for now because it's conflicting with the other routes here. My apologies. So that saved it. I'm going to go back, and we're simply going to type in /error. And so there you go. There, it's going through the error, but it doesn't seem to find the file we're looking for. So I believe I did something wrong here. All right, let's go take a look at what's going on here. So in send file, I'm joining their name dot slash. Oh, I made a mistake here. I need /public /500 HTML. So let's retry that. So going back here to the browser, I'm going to refresh that, and there you go. It's serving the content from that file specifically that we created. So we created that method so I could demonstrate how error 500 would work, because it only gets triggered when there's an error. All right, so back to the slides here. And so we've dealt with error pages. Now let's make this a little more interesting. We have an instance of MongoDB that we created in MLab. I'm assuming everyone's created that. If not, you can try that out later. But in order to connect to MongoDB, we're going to use something called Mongoose, which is an ORM or an ODM. It's basically an object data mapper. So it allows us to define a model in our application and then store that as is in the database. And that's one of the advantages of MongoDB, because you can store JSON documents directly without having to define relationships between tables and things like that. So there are pros and cons to it, but I've been able to build most applications without SQL databases in the past few years, mainly because you're able to scale your application in many ways. It may not be the most efficient database out there, but it certainly simplifies your development process significantly. Anyway, so let's get connected, Mongoose connected. We're going to do something similar to what we did with Express. So we're going to install the dependency, and we're going to reference it, and then we're going to focus on creating a CRUD API. So essentially, we're going to define a model in Mongoose, and then we're going to perform the CRUD operations on that model via the RESTful endpoints that we create. So let's get back into the code. All right, so I'm going to, so notice when we ran into that error, it also ended up printing the stack to the console because of this line 24 here. I'm going to stop the server, clear the console. I'm going to npm install Mongoose. All right. And what we're going to do is create a folder on the source called models. And on the models, let's go ahead and create a model called, let's make it a bit different from person. Let's call it customer. So I'm going to create a JavaScript file, and I will call it customer.model.js. I usually follow this pattern for naming conventions. I separate multiple words with a period, and I always keep them lowercase. That way it makes it very simple across larger teams, so you don't have to think about how to name files and stuff like that. All right, so let's go ahead and construct this model here. So the first thing we want to do is reference Mongoose. we already installed it, so that should be available there. And then we're going to connect to the database in this file itself, but ideally it's something that you can take out of this file and have a separate database.js file, which will do the connection to the database when the application starts. But in the essence of time, I'm just going to do it here. So let's set up some properties for the database. So in my case, I have this written down here. I'm just going to copy and paste it. Essentially, I have 4 attributes here pointing to my database server, the name of the database, the username, and password. Now this is my instance in MLab. And so if you go to your database instance in MLab, it should give you an option to see all these attributes and the connection string. So the next thing I want to do is connect Mongoose to the database. And this is something we want to do only once at the beginning of the program. So I'm going to use backticks, and here's the connection string. You will get this from MLab as well, but it's fairly straightforward. So you start with MongoDB : / and then we're going to specify the user : password, at server / database. So that would be server / database. All right, so that should generate the URI for connecting to the database. And finally, let's create. So Mongoose has 2 main components to it. The first is a schema, and the second is called a model, which is simply a higher order function that wraps around the schema, really. And it provides you with additional methods that you can use to make database queries and things like that. So let's define a customer schema next. And the way you do that is by creating a new instance of mongoose.schema. And let me, sorry, if you were not able to read this, there you go. So within the customer schema that we're defining, let's create a couple of attributes there. We're going to create an attribute called name, and we're going to tell it that the type is string. And then the next thing is, let's create something called email. And let's, instead of assigning it directly to string, I'm going to show you a couple other things you can do here. So we can also assign an object as a value there and define additional properties on there. So we're going to tell it that the type here is a string, and then it's a required property, and that it has to be unique. That way we don't end up with duplicates. And this validation is actually done on the application layer itself. So Mongo database is not doing the validation there. That's the advantage of using Mongoose, because Mongo is schemaless, and unless you explicitly configure some rules in MongoDB, it does not do any validation. All right, so now we have the customer schema. We're going to create a model and export it at the same time. So we're going to do module.exports equals mongoose.model, and then the first attribute is going to be the name of the model, and then followed by the reference to the schema object. Okay, so let's do a quick recap here. We referenced Mongoose. I defined some attributes, some variables here that help us construct the database connection string. And then we're connecting to the database, and we're defining a customer schema. We have 2 attributes in there: name, which is a simple string, and the email attribute has additional properties on it, which, sorry, I missed a D here, so it's supposed to be required. So essentially we're telling it that it needs to be unique and it must be present. And then finally we export it as a mongoose model. All right, so I'm going to save this, and we're going to create a route that's going to expose CRUD operations, and we're going to reference this customer model and then make some entries in the database and retrieve those and things like that. So I'm going to go into the routes folder and then create a JavaScript file called, let's just call it customer.js. And I'm going to switch to person quickly here. Essentially, this is what we want to do. We're just going to have to type it sort of all over again, but let's do it from scratch. So we're going to start out with referencing the customer model. So let's do let customer model equals require, and it's one folder above /models /customer.model. And then we also want to reference express. Oops. And then we want to create the router instance from that express reference. All right. So let's create a route that will allow us to create a new customer. So here we will create a new customer, and we're going to create what's called a post method. And notice that the type of operation you're trying to define, the verb itself is available as a method in Express. So on post, we're going to call it /customer. So what this will allow us to do is call into localhost 3000 /customer, and we're going to make a post request to it. And then there's a handler with request response that we're going to deal with here. So one of the things we need to do is when we're passing in the data for creating the customer object, we have we're going to pass it in the body as a JSON object. Now, Express does not know how to handle that by default, so we need to tell it what to do with it. So essentially, we're going to go back to index.js, and there is a package we need to install for it called body parser. And so let's go into the console, and we're going to do npm install body-parser. And what that's going to do is essentially look at the incoming request, and if the content type of that request is application/JSON, basically that means that the data in the body is a JSON string. In that case, the body parser will take that string, convert it to JSON, and write or create a property in the request object called body, and set the value there. So essentially, it's doing the work for us to parse that piece out. So let's see how that works here. So we're going to reference body parser. And we're going to, let's do this as the first thing coming in, mainly because then we can print whatever is being sent in our logger there. All right, so we're going to do app.use, and in this case, we wanted to use the JSON module. So it's essentially taking in any incoming JSON string and creating an attribute called body. So essentially what that lets us do is we can also print the body, if any, that's converted by this body parser. All right, so I'm going to save that and then go back to our customer.js file. So what happens here is that now we have access to request.body. Before adding the body parser, that didn't exist. So we would have to look at the raw data and then the content type, and then, you know, if it was JSON and all that stuff, then we'd have to kind of extract the right pieces and end up constructing that. So body parser is taking care of that for us. Now that's the power of Express. It has so many different kinds of plugins and middleware that most of your application can be composed of these middleware libraries. And you can, of course, write your own in certain cases. So in this case, what we want to do is let's make sure that request.body exists. So we're going to first check for that, and I'm going to remove that comment. And essentially, if it does not exist, we want to return a response with a status code of 400, which means it's a bad request, and send a string with that response. And let's say we tell it that request body is missing. So the recipient, the caller, sort of knows what's wrong exactly here. Now, in terms of these status messages, there's obviously a package out there. I think it's called HTTP status, which has a bunch of these status codes defined as enumerations. So you could refer to it by the text name itself instead of the number. And I would recommend using that in a real world project. Now, if the body is present, then now we want to create an instance of the customer model and save it to the database. So let's do that here with referencing the customer model and request. So we're going to pass in whatever was part of the request body and construct that model there. Essentially, what we're going to pass here is something like this. Let's say user equal to, we need a name, you know, so this is first name, last name, whatever, and then email, you know, email@gmail.com. The incoming object is going to be something like this. So that's what we're going to pass through over here. And we'll get to how to send that as well in Insomnia. All right, so the next thing I want to do is save that model. And essentially, that will communicate from Mongoose to the Mongo driver, which is going to then talk to Mongo database and tell it to take these details, the request.body object, and validate it via the customer model and save it to the database. So we're going to use promises here to sort of follow up on this request. So after we save, we're going to call then, and then is going to, I believe, respond with the document that it saved. And so what we're going to do is, if we weren't able to save the document, or it's an array of documents, I believe, or if document.length is 0, then we want to respond with an error. So let's say it's an internal server error, and we're going to send that document, which should be null in this case, or an empty array. And if that's not the case, then we want to respond with a status code of 201, which stands for resource was created. Now, this is sort of optional in a way. You could have responded with 200 as well, but that's where sort of REST sort of defines the guidelines, you know, for how things should be constructed. That's up to you as the programmer, as the developer, to figure out, to design the system and figure out what these response codes will be. And then you need to document it as part of your API that people will use to access your RESTful API. So here I'm going to respond back with the document that we just created. And then finally, we can also catch any exceptions. And so if there were any errors, those will be caught here. And so we'll sort of do the same thing as above, respond with an error code there. And then instead of send, we're going to call JSON, which is going to take in the error object and transform it and send it over instead of a specific message. This kind of gives us more details. Now it's up to you how you want to respond, in your projects and stuff. All right, so that should complete the customer creation process. I'm assuming we've done everything right here. Let's run the project here via npm run start watch. All right, so it's up and running. We're going to switch over to Insomnia, and we're going to create a new request. I'm going to call it post customer. And I accidentally set it to get here, but we're going to switch that over to a post. And then I'm going to call into our endpoint here, customer. And let's see what happens if I click send. So we get an error there. And guess what? We forgot to add this to the routes here. So we need to reference that. I'm going to get rid of the spaces here so that these are sort of organized nicely. So we're going to reference the, let's do it right by this other route here. We're going to call it customer route equals require dot slash routes slash customer. And then we're going to tell it to use the route here as well. So it's going to register that. And you need to be careful about the order as well. Essentially, you could mess things up by having an incorrect order where something might be returning earlier than you expect it to. Anyway, zap use, I think this. So sometimes NodeMon will crash and it may not restart. So at that point, what you can do is in your console, you can type in rs, which tells it to restart. And what's happening over here? Line 16, it does not like this because I think I missed something here in customer.js. Yep, so we're not, I believe we're not exporting that router. So that's what we want to do here. So module.exports equals router. There you go. Now it's going to, okay, so server started now. So a couple of things we had missed. One was to export the module, and the other was to actually import it and then tell Express to register those routes. So let's go back to Insomnia. And okay, so we're going to click send here again. So notice earlier it said we think you are lost. That's because it did not recognize that route, and it and the 404 handler, the resource not found handler kicked in, and you can see here the error code that was sent back. So let's click send here again. Now I get an internal server error, and it's giving us some details here. So we had responded with the entire error object. We could have simply responded with, let's say, the message here, but in our case, we were showing we were returning everything. So we know what's going on here. So let's change things around here in this post request. So the body part, I'm going to click on the drop down here, is going to be of type JSON. And then in there, we're going to pass in an object which has name. Let's call it Thomas Anderson. And then we have an email. Now, if I omitted the email, it would still complain about it too, because it's going to validate on the server side. So let's call it thomas@gmail.com. And essentially, I can, when I click send here, it says 201 created, and it's going to be responding with what it created. Internally, it's generating an ID for it as well, and it also tracks the version as you update the object. All right, so that was it for creating the entry in the database. Let's verify by going to robo3t. Now, assuming you've connected everything here, we're going to have a collection called customers. Mongoose will pluralize model names. So customer ends up becoming customers. I'm going to double click this, and that opens a new tab there. And there you go. It's going to show you a record that was created. So we had added these entries in there when we posted to the route. So there you go. That was that simple. I'm sure you may not remember a few things at this point, but that is okay. You know, a little bit of practice and then looking through documentation and other tutorials will definitely help you understand this better. So let's go back to the customer route. I'm going to go to the post here. And so we were ensuring that a body was present. We could have also checked for other attributes being present. So as part of body, we could have checked something like if not request.body.email, right? And then I could have done something here and responded. However, the customer model is actually validating some of that for us. So if things were missing here that the customer model expected, like email, for instance, then this catch block would be triggered and we would still get an error. So that's one of the advantages of using Mongoose. Anyway, so let's quickly add a couple other methods here. So we're going to next add the ability to retrieve this data. So we're going to create an endpoint called customer to get the customer. We're going to have the same format here again, request response. And one of the things we're going to do here is we're expecting an email. So we're going to look up the customer via email. So we're going to actually use the customer model directly. And the model gives us a few methods on it that allow us to search through a query through the content in this case. So we're going to call a method called find1. And Mongoose has a very rich API. It has a ton of functions that definitely are way out of scope for this workshop, but I would encourage you to look at their documentation. There are also lots of interesting articles out there that'll highlight some of those. But anyway, in this case, we're going to use find1, and find1 takes an object with attributes as the query parameter. So in this case, we're going to pass in the email, which we're expecting via query.email, for instance. And then, of course, we want to make sure that it exists up here. So we're going to check for request.query.email. If that's not present, we're going to respond with, respond with a status code of 400 resource. 400 is an error. And we're going to tell it that it's missing URL parameters. So let's do send missing URL parameter email. That's required. So that's going to exit out of there. If not, we should also have our document available on the then method that gets called. And what we can do is respond to the request with that document. If there is an error, we want to handle that here in the catch block and essentially respond back with the status code of 500 with this error object, and that should return the model there. I'm going to quickly add a couple of these other methods since we're almost out of time here. So the other is put, that allows us to update the existing customer, and all these have a similar format. What I'm going to do is I will copy some of these elements here and just paste it there. Essentially, I could use some of this, reuse some of that. So we have request response, and in this body here, we're going to I need the email piece as well. So we're going to check that there is an email present in the query. If not, we're going to call a method on the model called find1 and update. And essentially it's going to query based on this, and then it takes another parameter, which is your body in this case. So let's call into that. That would be request.body and body. And then you can pass an options object. In this case, the options basically one of the options we're going to pass it is to return the newly created or updated object. Otherwise, it returns the same it would return the same request body that you sent in. But since we want to make sure that the change actually went through, we want to do that, set that attribute. I have a typo here, so I'm going to change that to status. And then, so this was your post request. This is your get request. And then this is your update request. So the U in the CRUD. And customer, sorry, I have a few typos here. All right, so that'll update the existing object via a match on the email. And then finally, we want to be able to delete. So that would be router.delete. And again, very similar to this. So I'm just going to copy paste that part of the code as well. So essentially, you're calling into customer. We're going to make sure that email exists. And then there is a method called find one and remove, which will take in your email. And then we don't need the request body and the new pieces from above that we copied. And everything else here stays the same again. All right, so I think that covers the basic CRUD operations. And let's go into Insomnia and test it. So let's go down to, let's make sure the terminal is still okay. The project is still working fine. I'm going to switch over to Insomnia, and then I'm going to duplicate this and call it put customer. And essentially this method should be put, and we're expecting a query string called email. So we're going to pass in email equals thomas@gmail.com, and then we're going to send in the body here. Let's call it Thomas updated Anderson, and we're going to click send here, and there you go. It responded with an OK, and if you notice, the object that it responded with is the newly created object. And I think I made a mistake earlier when I mentioned that it responds with request.body. What I meant to say was it responds with the original object that it finds, and not the updated object. So let's duplicate this again, and there is we want to get customer in this case, and we're going to call that get here, and essentially we want to get this by again via email. So let's call this thomas@gmail.com, and then we don't need a JSON body here, so we're going to delete that, and you can leave that as is. And then if we click send here, it's going to retrieve whatever was sent in. And finally, I'm going to duplicate that again and call this delete customer. And so change that again to delete, and essentially the query string stays the same. I should be able to hit send, and then it says okay, it's responding with what was deleted. Let's say if I were to click send again, it's going to respond with a null because that object has been deleted already. So let's verify that by going into Robo3T. So here I can either, if you're on Windows, you can do Control R. On a Mac, it's Command R. And if I refresh it, you'll notice that the record has disappeared now. So most of those other methods were very similar in terms of the RESTful setup, as well as the attributes that were coming in and things that we were modifying and stuff like that. So let's do a quick recap here. We created a customer model, which is part of the customer model.js file. You're familiar with this by now. And so we reference that in customer.js. That's our route. And essentially we're creating a route here. The first piece is a create operation that's handled via the post verb, and it's calling into customer. We're expecting a body to be passed in. We added the reference to a body parser middleware for Express, which actually gives us that data that's passed in the body attribute. This was just an example here that we could check for an email to exist on that body as well. There's obviously a lot of error handling that you can do to make this more robust. And And essentially the object coming in will look something like this, that we're simply passing through to the customer model. So we create a new instance of the customer model with that incoming JSON object, and we call save on that model. And then basically there are two methods here on the sorry this is using promises. So promises have then and catch, and so we're handling different error conditions and whatnot here. So this is pretty straightforward here. I think the important piece is how to create that route and how to respond. You want to make sure you're passing back the right error codes and things like that, or status codes and things like that. Get request was very similar. You change the verb here, the method name that maps to get. Similar things here, just the method on your customer model changes. So essentially that was like the only big change between all the other methods on the route. So you have get, and on update you have find one and update, and for delete you have find one and remove. So I think that about wraps this up. I think that there was a lot of content that we crammed into this hour and a half, and sorry, someone says as a pure database person their brain hurts. I apologize. It's a lot of moving pieces here, and if you don't get it, it's okay, don't feel bad. It took me a long time to really understand this and master it. These things take time just because of changing APIs and also the variety of functions that they expose. So I want to do something real quick here before we end. So I'm going to clear my console here, and now we have our application here. We have a package JSON that defines the project and the scripts and things like that. There's a service called now.sh that essentially allows you to deploy your Node.js applications real quick. And so I will let you explore this, but what I'm going to do is simply deploy this to the cloud now. And so what I need to do is go into my application folder and I type in now. I have the now client installed via npm as a global, and they have all the instructions here on this site. But I simply want to show you how easy it is for us to get this up and running in the cloud. Since I'm using the free version, it's asking me a question that's stating that my application will be public. And so essentially what it's doing is it's zipping up the application. It's making sure that there's a package JSON that exists. It will upload that to the server side, and then it's unzipping it, and it is running the npm install command, which ends up setting up all the dependencies that we require for the project. And here you see it's done. It's giving you a status about what's going on. So it did a bunch of things here. It's telling you which version of Node it's using. There's an actual endpoint that it created for us, and it's copied it to the clipboard. It's synced all the 10 files. It's initializing its build process. It ran npm install. Package-lock.json is something new with npm 5. It allows you to replicate the exact versions of libraries that you used. And then I guess it was waiting to. So internally, it's running the npm start command. I think one of the things that I missed here in package.json I want to quickly add is we want to set the process environment variable, and essentially in index.js we were doing this here for port. So we want to make sure we're setting port, and it's as easy as going in here and setting port equal to whatever value that we would need. But anyway, I think this should be deployed already. I think it's copied, but I'm going to make sure I copy it again. And then we're going to go to the browser and let's put this in there. Let's see if that works. There you go. So we quickly got our application up and running in the cloud. And since we were using MLab, it's connected to the database. We didn't have to worry about uploading the database or installing a database and things like that. Of course, you would need to have a config file that then looks at the type of environment you're running in: development, staging, test, production, and then use the appropriate values from there to connect to the appropriate databases. But here you go. You can actually do this very quickly and play with it once you have your application up and running. There was a question here that says, do you usually need to use Mongoose to access a MongoDB? And the answer is no, you don't. The new MongoDB driver is definitely a lot more powerful lately, where it allows you to do validations as well. You can define a lot of those things. Several people prefer that approach. I personally have been using Mongoose for a while, so I stick with it because I'm familiar with the API, and it provides us with a lot of rich methods to handle these interfaces into the database. And I can also abstract my models out and add specific methods on it to do more complex operations. And so it sort of provided a very good plugin model for that. And so yeah, the answer is no, you don't have to use Mongoose, but it just simplifies a lot of the process there. I did write a couple of articles that might be useful. One of them was Introduction to Mongoose. I don't know if I can... Introduction to Mongoose there. This one specifically walks you through how to use Mongoose for MongoDB, and check it out, see what you think of it. There's also another one I have called building your how to build your own React boilerplate. This kind of introduces React into the mix, but it also walks you through some of these basic building blocks for creating Express servers and things like that. The idea was that most people start out with using some existing boilerplate, like create React app, for instance, but they don't understand the underlying building blocks. And that was the idea here, to break it down into individual pieces so you understand what's going on. Now, this one, of course, uses Webpack version 3. So I do plan on updating it with version 4, which is a lot easier, in case you're planning on reading this. Anyway, I think that about wraps it up. I apologize for going 10 minutes over here. I think, yeah, that was it. If you have any additional questions, please feel free to reach out directly to me or on Dev2. You can follow me on Twitter at TheOutlander. And I hope this was worth your time. Hope you get to play with this further and make sure you explore all the APIs. Look up the documentation for Express, for Mongoose. Check out now.sh, which will allow you to deploy your application very quickly compared to AWS, and even Heroku is pretty fast, but now just takes it to a whole new level where all you type is now and it gives you this URL with your application, and you can map a domain name to it directly and scale very easily. And I have used a ton of cloud providers, and I absolutely love Now and would highly recommend it. Alrighty, thank you so much. I'm going to pause this session here, and hope to hear from you soon. Bye-bye.